Hi everyone, for today's lesson we are going to continue our discussion on measuring and classifying angles. Our warm-up for today is to analyze the hands of a clock and to find out what measure the clock is making. So let's go ahead and look at our first example. Now whenever we are measuring, we always want to measure from the small hand and measure counterclockwise. So what counterclockwise means is that we are going to be going backwards clockwise. So clockwise is going all the way, so clockwise looks like going all the way around a clock. Counter means the word backwards. So we are going to be going backwards. Counterclockwise is backwards clockwise. So it's going around the circle counterclockwise, going around and around that way. So I know it kind of looks like a crazy picture. This is counterclockwise, going backwards clockwise. All right, so it says, what is the measure of the angle and the type of angle? So we want to find the measure, which is degrees, and the type of angle. Remember that there are 4 different types. There's acute, right, obtuse, and straight. So acute, right, obtuse, and straight. All right, let's go ahead and look at example letter A. Let's draw 3 o'clock. So remember that in 3 o'clock we have the little hand and the big hand. So the big hand always stays where it's at, and the little hand is what goes all the way around. So I'm always going to start with my hand on my clock being at 12 o'clock. So I'm going to do like a center right here. Let me make sure it looks center. And I'm going to draw my hand going straight up. And 3 o'clock, well, 3 o'clock is pointing at 3. What angle do we see here? Well, that's going to be a right angle. So that's a 90-degree angle, or a right angle for 3 o'clock. Let's go ahead and look at 6 o'clock. So 6 o'clock means that we have our clock is pointing up at 12, and then we have it going down here at 6. So going from 12 all the way to 6, well, that big angle right here is a straight angle, and we would call that 180 degrees. This is a straight angle. Let's look at 1 o'clock. I'm going to use a different color this time. Here is 1 o'clock. So we have pointing up at 12, and then here is 1 o'clock. How would we figure this out? Well, one thing that we can do is we can use a protractor. Now, I recognize that not everyone has a protractor, so I'm going to be doing this for you guys so that you can see, and you will not be required to use a protractor, like have that as a tool for this class, but you will need to be able to analyze it. So what I'm going to do is I'm going to line up with the big hand, or with the small hand, which is what I have right here. And I'm going to do the very best of my ability to line it up to as best I can. And I know it's kind of hard to see, but if you can imagine just pretending as if I perfectly did this, starting at 0, going all the way around, it appears to be about 30 degrees. So just be open to the fact that it's not going to be 100% perfect because I'm writing it, but it's 30 degrees, and 30 degrees is smaller than 90 degrees, so that is going to be an acute angle. Let's go ahead and look at 4 o'clock. I'm going to use a different color to represent 4 o'clock. So here is 4 o'clock. And to help me, I'm going to extend out the line of 4 o'clock so that I can create or use my, my protractor. And I'm going to line up my protractor so that it's down here with 0. And I'm looking for it to line all the way up. So let's see, did I draw that correctly? All right, let's go ahead and zoom in. So here is 4 o'clock. So my line starts right here, it's red, and it goes all the way around to this line right here, and it appears to be located at about 110 degrees. So looking at this angle, it goes all the way around to about 110 degrees. And 110 degrees, that is bigger than 90 degrees, but smaller than 180, so we call it an obtuse angle. So what we want to do now is we want to find different times than those that we have above here. Which ones would create 60-degree angles? Well, typically, like if this angle right here was about 30, it's supposed to be that every time that you go around, it's supposed to be another 20 degree or another 30 degrees. So this is supposed to be 30 degrees, and this is supposed to be 30 degrees going all the way around. Look at this, 30, 30, 30. It's supposed to be 30 degrees going all the way around. That's the way it's supposed to be, if your clock is correct. So one that is 60 degrees, if we go 30, 60, so another time that would be 60 degrees would be like 2 o'clock. 2 o'clock would make 60 degrees. 150, so all the way around is 180. 180 minus 30 degrees is 150 degrees, and that is located at 5 o'clock. What angle is the measure that's 5 o'clock? So 5 o'clock, once again, is 150 degrees. And 10 o'clock. 10 o'clock is just like 2 o'clock, right here with this angle. If it's 30, 60 on one side, it would be 30, 60 on the other side. So this would be 30 degrees and 30 degrees, so that would be 60 degrees. I know that this might be a little bit confusing, but this was just supposed to be an application of how we can analyze different angles. All right, let's go ahead and look at example number 1. So in example number 1, what we want to do is we are given the measure of angle GFJ. So we're told that angle GFJ, so I'm going to highlight that. Angle GFJ, which is the whole angle, is 155 degrees. They're asking us to find the measure of angle GFH and angle HFJ. So there are 2 angles that we have in here. And what this is it's an application of the angle addition postulate, in which the angle addition postulate said part plus part equals whole. Now, anywhere in this problem, do you see the word bisect? No. Bisect is not in here. So that means that these 2 angles have completely different measures with completely different arc marks. So what we're going to do to solve this problem is we need to identify what x is equal to. Then we're going to find the measure of angle GFH. And then we're going to find the measure of angle HFJ. So we have 3 pieces of information that we need to find. But what I do know is that one part plus the other part equals the whole. So I'm going to say that since measure of angle GFH is 4x plus 4, I'm going to add it to the measure of angle HFJ, which is 4x minus 1. And I'm going to set it equal to 155 degrees. Now I'm going to combine my like terms, so I end up with 8x plus 3, so 4 minus 1 is 3, is equal to 155. I'm going to subtract 3 on both sides, and when I do that, I end up with 8x is equal to 152. Now I'm going to divide both sides by 8. And when I do that, I find that x is equal to 19. So now that I know that x is equal to 19, I can now find the measure of my missing angles. So I'm going to substitute 19 into 4x plus 4 to help me find the measure of angle GFH. So I'm going to write measure of angle GFH is equal to 4 times 19 plus 4. So 4 times 19, that is equal, plus 4 is equal to 80. 80 degrees. Since we are talking about the measure of an angle, that means that we need to make sure that we put a degree symbol. Notice x equals 19 does not have a degree symbol, and that's because x is not an angle. So only angle measures would have degree symbols. Now, to find the measure of angle HFJ, there are two approaches. One approach is to substitute 19 back into the original expression. So to say the measure of angle HFJ is equal to 4 times 19 minus 1. So 4 times 19 minus 1, if you were to put that into your calculator, is 75 degrees. Let's see. Is 80 plus 75 equal to 155? Yes, it is. So that is a correct answer. Another way to have come up with this angle, or this answer, is to go 155 minus 80, and that would give you 75 as well. Both approaches would still get you the same exact answer. All right, let's go ahead and move on to the next example. In this example, it says, given that angle VRS is a right angle. So what do we know about right angles? Hold on just 1 second. Let me make this not so blurry. There we go. What do we know about right angles? Well, right angles have a measure of 90 degrees. So now we're going to try to find the measure of angle VRT and the measure of angle TRS. So we know this whole angle is 90 degrees. In this problem, do you see the word bisect? No. So because you do not see the word bisect, we cannot set these two angles equal to each other. They have completely different measures. So they'll have completely different arc marks. So we cannot say that they are equal to each other. Instead, what we can say is that x minus 4 plus 3x plus 2 is equal to 90 degrees. We can set up this equation. And our goal is to find what x is equal to, and then what the measure of angle VRT is. And finally, what the measure of TRV is. So that's what we need to find. All right, let's go ahead and solve for x. X plus 3x is 4x. Minus 4 plus 2, that is minus 2 equals 90. I'm going to add 2 to both sides, and when I do that, I end up with 4x is equal to 92. Dividing both sides by 4, 92 divided by 4 is equal to 23. So now that I know that x is equal to 23, I am now going to find the measure of angle VRT and the measure of angle TRV. I'm sorry, not V, this is S. Sorry guys, that's an S right there. TRS, there we go. So let's find VRT first. So V to R to T is x minus 4. So the measure of angle VRT is going to be equal to 23 minus 4, which is 19. So I'm going to put 19 right here. To find the measure of angle TRS, you could plug 19 back into this original 3x plus 2, or what you could do is take the whole angle measure, which is 90 degrees, and subtract away what we just found, which is 19. So 90 minus 19 is equal to 71. So our answer is 71 degrees. And I forgot my degree symbol right here, but you have to remember that whenever you're dealing with angles, we need degree symbols. All right, let's go ahead and look at example number 3. For example number 3, it says, find the measure of angle ABD. So the measure of angle ABD is just this angle. And, I don't know any information, but I can clearly tell that this angle is not the same measure as this angle. So all the other ones, they told me what it was. This was a 90-degree angle. In our previous example, they told us that this was 155 degrees. And how are we going to use part plus part equals whole? What are we going to do? Well, what kind of angle is angle ABC? Well, here's ABC. ABC is a straight angle. And because it's a straight angle, its measure is 180 degrees. So nowhere in this problem do you see the word bisect. So we cannot just say that these two angles are equal to each other. Instead, what we're going to say is that 5x plus 10 plus 2x minus 5 is equal to 180 degrees. We're going to use part plus part equals the whole because we know that the whole angle is 180 degrees. In this problem, we want to just find what the measure of angle ABD is. So we simply need to find what x is equal to, and then what is the measure of angle ABD. So combining my like terms, I have 5x plus 2x, which is 7x. 10x minus 5x, which is plus 5. 10 plus or minus 5, which is plus 5, equals 180. I'm going to subtract 5 on both sides. And when I do that, I end up with 7x equals 175. I'm going to divide both sides by 7, and as long as you have a calculator, I think you should be okay. But we find that x is equal to 25. Now, that is a great answer, but it doesn't answer the question. So the question is asking you to find the measure of angle ABD. So we're just interested in the orange angle. That's it. So I am going to substitute 25 into the measure of angle ABD, which is 5 times 25 plus 10. So 5 times 25 is 100. 25 plus 10, which is 135. So our answer is 135 degrees. Example number 4 is a little bit different. In this diagram, we are told that ray WY bisects. Finally, we've gotten to that word bisects. Bisects angle XWZ. And notice in this picture, we have ourselves the same arc mark inside of our angles. And if we know that the measure of angle XWY, so let's go ahead and find where XWY is. We're told that the measure of angle XWY is 29 degrees. They're asking us to find the measure of XWZ. So here is XWZ. So there are a couple ways for you to do this problem. We know that each piece, because of that word bisect, which bisect means to cut in half, each piece is 29 degrees. So that means that the full angle, the measure of angle XWZ, has to be equal to 29 plus 29. 29 plus 29 is equal to 58 degrees. That is one way for you to solve that problem. Or another way that you could solve it is you could take the measure of angle XWZ is equal to 2 times 29, which is still going to be 58 degrees. So there are two ways in order for us to come up with this answer. And that is either to simply add the two angles together or to double them. So once again, when you see that word bisect in the problem, you're going to set two algebraic expressions or two numbers equal to each other. So this is going to correspond to what we are going to do in example number 5. You set them equal to each other. And that's because bisect means to cut in half, and to cut in half into two congruent pieces, or those with equal measure or length. In this problem, we have ray CW bisects, there's that word bisect again, bisects angle SCP. Let's draw this picture. All right, so I'm going to draw angle SCP. I don't know what that angle looks like, but I'm going to do the very best I can with it. And here is SCP. And I'm told that CW bisects it. So I'm going to try the very best that I can to draw an CW bisecting, which means that each side is going to be congruent. We want to find the measure of angle SCP, given that the measure of angle SCW is x plus 13, and the measure of angle WCP is 3x minus 17. So let's go ahead and insert that information. Measure of angle SCW, so here's SCW, is x plus 13 degrees. So I'm just going to put that in parentheses just like I see it. We're going to drop the parentheses whenever we are finding x and finding our angle measures, but this is just establishing that it's the whole angle to the degree, or the whole value degrees. WCP, measure of angle WCP, that is 3x minus 17 degrees. I do not know how big the big angle is, and so because I do not know how big that big angle is, I know that these two other angles are congruent to each other, so I'm going to set the two expressions equal to each other. So I'm going to set x plus 13 equal to 3x minus 17. And once again, we are only allowed to do that because of the word bisect. So in this problem, we're going to find what x is equal to, and then we're going to identify what the measure of angle SCP is. All right, so let's go ahead and see what we can find. So I'm going to start off by subtracting x on both sides, and why I'm doing that is so that I can have my coefficient be a positive number. And I'm going to add 17 to both sides. I like to do more than one step in one step because I think it saves a lot of time. And so 13 plus 17 is equal to 30, and 3x minus x is 2x. I'm going to divide both sides by 2, and I find that x is equal to 15. So I'm going to put 15 right here. Now I need to find what SCP is, but before I do that, I need to know what the parts are equal to. So I know that SCW, the measure of angle SCW, that's going to be equal to 15 plus 13. And 15 plus 13, that is equal to 28 degrees. So that means this angle is 28 degrees, and the other angle is 28 degrees. So the measure of angle SCP, that has to be 2 times 28, and 2 times 28 is 56 degrees. You could also simply do 28 plus 28, and that will also give you 56 degrees. Both approaches will give you the exact same answer. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.